Hello and thank you for coming aboard this tour of application data at Google. I'm Chris Ramsdale, Product Manager for Google App Engine. I'd like to begin with some quick trivia to provide some context for the capabilities and products I'm going to talk about today. Every minute, over 60 hours of video is uploaded to YouTube. Google's caffeine search index was over 100 million gigabytes in June of 2010, and growing very quickly. There are over 350 million active Gmail users, and it takes Google approximately 1/4 of a second to respond to a search query. So what did Google learn building these products? At Google, the reliability and performance of the systems we build are critical to our business. We realized that traditional data solutions just wouldn't do what we needed them to do. The kind of scale we're talking about here requires that we do things differently. So we spent more than a decade building data systems that are extremely reliable and available, have multiple layers of redundancy, and can handle the loss of any given data center, and are wicked fast. We published the details of our early infrastructure, MapReduce, Bigtable, and the Google file system, which became the model that was adopted by the open source community that sprung up around big data. But those were just the table stakes. Whether to deliver high-quality search results, relevant advertising, or just to learn how to continually improve our algorithms and systems. At Google, we believe fast is better than slow, and our focus on performance is very pervasive through the systems and products we build. At the core of our data offerings are services that help businesses store and access their data in the Google Cloud using the same technology that we use to run our business. Google Cloud Storage for unstructured content like files and media, the App Engine Data Store that provides a NoSQL environment for structured data, and Google Cloud SQL for relational data. Google's mission is to organize the world's information and make it universally accessible and useful, which meant that we got very good at finding out the meaning of data and doing so very quickly. As the business and data landscapes have evolved, some of the problems that we set out to solve that seemed fairly specialized to our business are now pervasive in the industry. Data is a core business asset, becoming ever more important as a competitive advantage. There are fewer and fewer low-hanging fruit. At the same time, data is growing faster than most organizations' ability to leverage or even capture it. Going from a few gigabytes to several terabytes to petabytes of data has fundamentally changed the tools needed to work it, and traditional BI is struggling to keep up. Several commercial and open source initiatives have sprung up to solve these problems, many of which are based on technical papers that Google wrote to share its innovations with the world. Hadoop is based on Google's MapReduce technical paper, HDFS on the Google file system, and HBase on Bigtable. In the years since we published those technical papers, our technology has continued to evolve, and now we're starting to make our latest and greatest data tools available as cloud-based services. In the Google Cloud, you can use App Engine to build scalable web applications with high productivity and low time to market. Google BigQuery lets you unlock the insights hidden in large data sets, and the Google Prediction API enables you to use Google's machine learning technology with your data. Beyond storing and accessing your data, though, we're really focused on making that data useful through an integrated platform of data services, premium APIs, and platform services that let you store, analyze, and leverage your data in your own applications. I'll talk a bit more about leveraging your data in the Google Cloud in a little while. Let's first look at the core data services. First, Google Cloud Storage. This product was built from the ground up to store unstructured data with high reliability, availability, and performance, and to allow you to seamlessly scale your data as your needs grow. Data is stored with multiple levels of redundancy for high availability and performance. One of the many benefits of using Google Cloud Storage is that you put Google's network to work for you. When you store your data in the cloud, you quickly realize that cloud services live and die by the network. That's been an area of significant investment by Google, and we think it shows in the quality of service. At high scale, reliable storage has many uses in and of itself. In order of increasing value, you can use it as a tape replacement strategy for your data backups. Use it for active archives, storing your data archives in the cloud for easy access and no maintenance overheads. You can use it for all kinds of content and media serving applications. To quickly and easily share data with the organization, with a small or large group of external partners or customers, or freely over the internet. You can use it to store data for your applications, or in conjunction with some of our other services for analysis and computation. When most people think about their structured data strategy, they think about two kinds of products. NoSQL data stores that offer very high scale and support for millions of queries per second, usually in exchange for less rich data representation, typically their denormalized data, and or trade-offs in data consistency. SQL-based data stores that are well suited for applications that need relational data, but cannot deliver the kind of global scale and performance that NoSQL stores can. At Google, we believe that each has its own place. The App Engine high replication data store is based on Google's Megastore technology and combines the scalability and performance benefits of a NoSQL data store with high availability, transactional capabilities, a flexible query engine, and strong consistency guarantees. The data store is schemaless, which means your data structure can be flexible and evolve with your needs. Unlike many NoSQL solutions, it doesn't sacrifice consistency. It offers the ability to perform ACID operations within transactions and consistent reads outside. It's a very reliable service too. Data is written to multiple data centers, making it capable of withstanding multiple data center failures. The high replication data store has had 100% uptime since its launch a year ago. But to get all these benefits, you do need to think differently. You can't use tools that depend on traditional SQL databases. You need to denormalize your data. These trade-offs make the data store most suitable for data sets that need to scale seamlessly and deliver high performance and availability. For those applications that do not need the kind of scale that the data store provides and that benefit from the ability to use a traditional database, we recently launched Google Cloud SQL as an experimental service that is open for public use. This new service gives you a fully managed MySQL database in the Google Cloud, so you can use more traditional tools and represent your relational data effectively. The data is replicated for availability. Once your data is in the cloud, you can make use of other Google technologies. BigQuery is a fully hosted cloud data analysis service that enables you to get critical insights from multi-terabyte data sets at near real-time speeds. It's built on Google's infrastructure based on production tools used by Google to build its own big data business. You can perform SQL-like queries via UI or API to gain insights from your data, share and distribute them, build your applications, dashboards, etc. It offers some unique benefits. You can find a needle in a haystack, tens of terabytes. You can get near instant results and unlimited scale. No maintenance and no long-term commitments needed. We think that BigQuery represents a discontinuity in what you can do with data. You can reduce time to insight from weeks to minutes, allowing your business to move faster. You can get straight to business insights without building and maintaining a data center, developing specialized technical capabilities, or licensing expensive software. You don't need to build indexes to do traditional BI planning, so you can be more flexible. Because let's face it, it's practically impossible to know all the questions you'll need to ask beforehand. For when you need to build data-centric applications, we offer Google App Engine, which lets you build internet-scale applications quickly, easily, and cost-effectively. You only pay for the resources you use, which means you don't need to do complex capacity planning or keep large amounts of rarely used buffer capacity on hand. The data generated by your applications can be quickly analyzed using Google Cloud Storage and BigQuery. App Engine is also a great way to build applications that provide reporting, dashboarding, and other capabilities to your business, your partners, or even your customers. I'd like to spend a couple of minutes talking about a few illustrative cases where people have leveraged Google's technology to power their data. DNA Nexus is a Bay Area-based company focused on unlocking the potential of DNA-based medicine and biotechnology with a collaborative and scalable data technology platform built on the cloud. They wanted to give researchers around the world tools to search for and access sequence read archive datasets. They had an ambitious goal: to completely re-engineer how researchers interacted with the data, mine results, and download datasets of interest. By using Google Cloud Storage to store and serve the data, they were able to quickly build a web-based interface to the SRA datasets that had garnered praise from the research community. Crystalloids is an Amsterdam-based analytics firm that helps businesses analyze massive amounts of data to improve profitability. They first used Google BigQuery and Cloud Storage to provide a customized product for one of their customers. Based on their success with this project, they launched Crystalloids Innovations, a subsidiary that offers cloud-based tools to the retail and hospitality industry. Daffodil Software provides a suite of web-based applications, including a business customer relationship management, otherwise known as CRM, program, and an enterprise resource planning ERP app for schools. Daffodil needed a cloud-based hosting platform for its applications that would save money and time over in-house hosting. They built their applications using Google App Engine and Google Cloud SQL. So in conclusion, you can now put Google's technology to work for you. You can store and access your structured and unstructured data, mine your data for insights, and build new applications and capabilities quickly and effectively. In return, you can capture more data, gain business and competitive advantages by unlocking insights and data sets of any size, and you can do so cost effectively. Thanks for watching. I hope this helps you understand how you can use Google's infrastructure to store your application's data and power your business. For more information, be sure to check out developers.google.com.